So chapter 9 continues with trends like we saw many of with periodic trends in chapter 8. But in this case, we're talking about covalent bonds, and we're going to think about covalent bond length and covalent bond strength. And so we have two examples to think about here. So anytime you have any of these problems where you're trying to rank something, the first thing you should probably ask yourself is what's different. So when we look at this first set of compounds, what's the same is that it's sulfur bonded to 3 different halogen species. So again, if we look at these halogens, we can see fluorine, bromine, and chlorine. And so what we want to think about here is what happens as we have sulfur bonded to the smallest, medium-sized, and biggest of these halogens that are present in this series. Well, hopefully the trend makes sense to you that the bigger the halogen we have to bond to the sulfur atom, the longer the bond's going to be. Because remember, to form a bond, we have to overlap the electron clouds, and the electron cloud is just that much bigger for bromine because that atom is that much bigger. So the longest bond is going to be the SBr, then the SCl, then the SF. So again, this problem asks us to rank them in terms of decreasing bond length. So the longest bond is going to be the SBr bond. And again, that's because this is the largest atom in that series of 3. That's going to be greater than the SCl bond, which will be greater than the SF bond. So see if this trend makes sense. The longer a bond is, the easier it's going to be to break. Okay, so long bonds equals weaker bonds. Okay, we've got much more electron density. We've got those electrons further out from the positively charged nucleus, and so all kinds of things kind of brought together make longer bonds weaker bonds. So if we can just figure out bond length, that'll directly tell us the trend with bond strength because they are inversely related. Okay, large bonds mean small energies to break them, so weaker bonds. Okay, so if we're going to look at these, we can actually show, so this is length. So if we show strength, okay, and we show the same trend decreasing bond strength, the strongest bond is now going to be this guy. So the shortest bond is going to be the strongest bond, then that guy, and then finally our sulfur bromine bond. Sulfur bromine. Okay, so this problem, we looked at differing lengths that we could see by looking at different sizes of the atoms. Our next problem, again, it's the same atoms, so what's different is the bond order. So trends with bond order is the more electron density you have between the atoms because you're going from, for example, a single to a double to a triple bond. A triple bond here is going to be the shortest bond. So again, if we rank them similarly as we did in this first problem with decreasing bond length, the longest bond is going to be our single bond. So single bonds are going to be longer than double bonds, which are going to be longer than triple bonds. So again, we had to ask the question, what's different? Well, the atoms aren't different in this problem. What's different is the bond order. Okay, so again, the same thing applies. Long bonds are going to be weaker bonds. So again, if this is length, this is going to be the longest because it's the smallest bond order. Okay? So again, the same trend is going to be true here, that whatever the shortest bond was, that's going to be our strongest bond. So again, if we rank these in terms of strength, the shortest bond is going to be our strongest. The carbon double bond is in the middle, and then the carbon-oxygen single bond is going to be the weakest bond as well as the longest bond.